Okay, so this says an isosceles right triangle with legs of length s has area 1/2 s squared. All right, that makes sense. I'm just going to draw it anyway. Okay, so these would be my two sides that match s. So obviously a equals 1/2 s squared. Okay, and at the instant when s is root 32 centimeters, the area of the triangle is increasing at a rate of 12 square centimeters per second. So, okay, at the instant when s is root 32, the area of the triangle is increasing at a rate of 12 square centimeters per second. So, like, let's turn that into not something we know. So the area of the triangle is increasing. So that means dA dt is equal to 12 square centimeters per second. And it's at this instant. It's when s is equal to the square root of 32. At what rate is the length of the hypotenuse? Okay, so we want, at what length of the ring is the, at what rate is the length of the hypotenuse? So why don't we call this L? We want dL dt of the hypotenuse of the triangle is increasing in centimeters per second at that instant. So we want it at the same instant. So we might as well just say, okay, so let's try to put this together. So like we could begin with our L here, right? Like what relates L and S in this diagram? The Pythagorean theorem. So that means s squared plus s squared is equal to L squared. Or why don't we clean that up to say 2s squared is equal to L squared. And now we'll do the derivatives of both sides with respect to time. So that says 4s times ds dt is equal to 2l times dl dt. And we want this. And we don't know, so and we know dA dt. We don't know, we do know that the instant is when s is root 32. So like that becomes a root 32. We don't know L, but we do know at this instant we can find L. So at this moment, right, at this instant, we have this diagram. So at this instant, the sides are root 32. And so by the Pythagorean theorem, right, okay, we can just use our 2s squared equals L squared above. So L squared is equal to 2 times 32, which is 64. So L must be 8. All right, so L is 8 at this moment. So that goes here. What about ds dt? Like, there's no info directly given about ds dt, but there is one piece of info we haven't used yet, which is that dA dt is 12. So let's go use our dA dt formula. This one has a couple digressions, huh? So we know that dA dt, just based on this relationship, dA dt is equal to power rule s times ds dt. We know at this instant, s is supposed to be root 32. We're trying to find ds dt, and we're also told at this instant that dA dt is 12. So that means ds dt is 12 divided by the square root of 32. And now we can put that in. That can go right, oh, I guess I used purple. Never mind, go back to purple. So now this goes right here. And s is root 32. So now we get 4 times the square root of 32 times 12 divided by the square root of 32 is equal to 2. Our length L is 8 times dL dt. And let's see, these conveniently cancel. And I get 4 times 12 is 48 is equal to, this is 16 dL dt. And then dividing both sides by 16 gives me that, what is that, 3? is equal to dl dt. So it would be 3, what's the unit? Meters per, or centimeters per second. 3 centimeters per second. And that's, sorry, it's so small, but there it is, answer choice B.